Hello, chemists. We're going to be talking about ionic product today. Ionic product is very similar to solubility product, but it has some important differences that I'm going to get into shortly. So the first thing to know is that the ionic product helps us to predict the maximum concentration of ions in solution at a given temperature and whether precipitation will occur or not. So basically, we're predicting what's going to happen with a given solution. Will we get a precipitate? Will we not? And what temperatures various things will happen at. And you can calculate ionic product whenever ions are present in a solution. So any solution can have an ionic product. That means that the ionic product can occur in solutions that are not at equilibrium. We will be using it mostly at equilibrium, but it can happen for any solution. And it is the product of the concentration of the ions raised to the same powers as in Ks. What that means is you calculate it exactly the same way that you calculate K sub S. And if the IP is bigger than the Ks, the solubility product, then you're going to get a precipitate. So far, simple enough. So if you think about a solution of lead hydroxide, you can calculate the ionic product like this. And it looks, like I said, very similar to how you calculate K sub S. The difference is that ionic product can, again, be calculated for products that are not at saturation. Products that are not even at equilibrium. If the lead hydroxide solution is saturated, then K sub S and ionic product, then solubility product and ionic product will be equal to each other. So in saturated solutions, they are exactly the same. They will be equal to each other. And in fact, you call the ionic product the solubility product only when the solution is saturated. Otherwise, there are other situations. Sometimes you can have a solubility product that is less or greater than the ionic product, i.e. the ionic product is less than the solubility product. That means that the solution is not saturated and you can add more stuff. Basically, you've combined two solutions and the resulting solution is not saturated. You can add more stuff to it. They are equal to each other. That means that the system is at equilibrium and is saturated. Or the ionic product is greater than the solubility product. That means that the solution is supersaturated and you are definitely going to get some precipitation. Supersaturated means it is past the point of saturation and it's wanting to shift back in the other direction. You will get some solid precipitating out. And that precipitation will continue until the solution has returned to its saturated point. So it'll precipitate basically backwards. So this K sub S, this lead hydroxide, has got the K sub S equal to 6 times 10 to the negative 16th at 25 degrees C. If the ionic product is greater than that, the solution is not saturated at all, you could add more stuff if you need to, or it has not reached equilibrium yet. You can have this saturated solution where they're equal to each other, and this one where the ionic product is greater than the solubility product, and then it's going to precipitate out. And when you're combining these solutions, it's important to use the combined volume to get the diluted ion concentrations. So you should be using the dilution factor calculations when you do these as well. So for instance, if you've got 10 milliliters of a 0.1 molar solution mixed with another 10 milliliters of another solution, the resulting mixture will have a greater volume than either of the two solutions did before, which means it will have a different concentration. The concentration of the original solution has been halved to 0.05 moles per liter. So just something to keep in mind. Another video will come later where I work my way through a example calculation. Thank you very much.